How can you simplify stoichiometry for chemical energy calculations? Imagine trying to solve a puzzle where each piece represents a part of a chemical reaction. Now, think about how energy fits into that puzzle. It can seem complicated at first, but with a few simple steps, you can make it much easier. Stoichiometry is all about understanding how much of each substance reacts and how much energy is involved. When dealing with chemical energy, like heat released or absorbed, it helps to see energy as part of the reaction, just like a reactant or product. The key is to use the balanced chemical equation, which shows the exact ratios of reactants and products. These ratios are the foundation for all calculations. Start by looking at the balanced equation. It tells you how many moles of each substance are involved. For example, if you have a reaction where hydrogen gas reacts with chlorine gas to make hydrochloric acid, the equation will show the number of moles of each substance involved. It also includes the enthalpy change, which is the amount of heat energy released or absorbed during the reaction. Think of this enthalpy change as a coefficient, just like the number of molecules. Next, identify what you know. Do you have the mass of a substance, the energy involved, or the number of moles? Convert what you have into moles if it's not already. This is important because stoichiometry calculations work best with moles. Once you have the moles, use the mole ratios from the balanced equation to relate your known substance to the unknown. Now, bring in the energy. If the reaction releases heat, you can multiply the number of moles by the enthalpy change per mole to find the total energy released. If you know the energy, you can work backwards to find out how many moles of a substance reacted. This step makes it easy to connect the amount of substances to the energy involved. Finally, don't forget to convert units back if needed. For example, if you want the energy in joules but your enthalpy change is in kilojoules, just multiply or divide accordingly. Think of energy as another reactant or product in the equation. By doing this, you can use the same straightforward mole ratio method you use for substances. This approach helps you avoid confusion and makes thermodynamics easier to understand. For example, if hydrogen gas reacts with chlorine gas to produce hydrochloric acid, and you know the energy released per mole, you can easily find out how much energy was released based on how many moles of hydrochloric acid formed. Or, if you know the energy involved, you can determine how many moles of reactants were used up. This method links chemical energy directly to the amounts of substances involved, making calculations clearer and more practical. It's especially useful in real-world situations like calculating fuel energy, understanding heat in engines, or figuring out energy needs in factories. In short, simplifying stoichiometry for chemical energy calculations means balancing the reaction, treating energy as part of the equation, using mole ratios consistently, and converting units carefully. This way, you can see how energy and substances connect in any chemical reaction, making thermodynamics much more approachable.